morning, students. In the previous class, one of the colligative property we are discussed, that is the relative lowering of vapor pressure. This we are discussed in the previous class. In this class, we are going to be discussing about the another second one, that is a colligative property that we call as a elevation of boiling point of solvent. That is elevation of boiling point. Elevation of boiling point. First, what do you mean by boiling point of a liquid? That is, the boiling point of a liquid can be defined as, that is the temperature at which the vapor pressure of the liquid becomes equal to the atmospheric pressure. That we call as a boiling point of a liquid. Boiling point of a liquid na yav tara define ಮಾಡ್ತೀವಿ ಅಂದ್ರೆ ಏನಾಗಬೇಕು, temperature at which the that is vapor pressure ಏನಾಗಿರಬೇಕು, vapor pressure of the liquid equal ಆಗಬೇಕು. ಯಾವುದಕ್ಕೆ? atmospheric pressure ಗೆ equal ಆಗಬೇಕು. ಅಂತದನ್ನ ನಾವು ಏನಂತ ಕರೀತೀವಿ ಅಂದ್ರೆ the boiling point of a liquid. The boiling point of a liquid is defined as that is temperature at which the vapor pressure of liquid is equal to or becomes equal to the atmospheric pressure. This we know that already relative lowering of vapor pressure we are discussed that the vapor pressure of the non-volatile solute in a volatile solvent, that is the vapor pressure of the non-volatile solute in a volatile solvent is lower than the pure solvent. Pure solvent compare ಮಾಡಿದ್ರೆ ಏನಾಗಿರುತ್ತೆ, solution, that is non-volatile solute in the solvent is nothing but it is a solution ಏನಾಗಿರುತ್ತೆ, vapor pressure ಕಮ್ಮಿ ಆಗಿರುತ್ತೆ. It is a lesser, that is vapor pressure of non-volatile solute in a solvent is lower than that is a pure solvent. Other words, we can say that the boiling point of the solution is higher than the boiling point of the pure solvent. In this, just we can consider that is 1 gram of sucrose. Just let us consider 1 gram of sucrose in 1000 gram of water boils at 373 Kelvin is nothing but 100 degree Celsius at atmospheric pressure. Now let it be the that is the TB naught is, we are going to be taken as TB naught is the boiling point of pure solvent, then and TB be the boiling point of solution. Here, according to the concept, the boiling point of the solution is higher than the boiling point of the solvent. Here, the increase in the boiling point is called as a elevation of boiling point. You can observe. I'll draw a graph for this. that is the graph is drawn, that is the vapor pressure versus the temperature, the vapor pressure versus the temperature. The vapor pressure in the y-axis, vapor pressure in the y-axis and temperature in the x-axis. This we call as a x-axis, this we call as a y-axis. This is a particular pressure, that is one atmospheric pressure. We are going to be taken as is one atmospheric pressure that we are going to be. There is about the one atmospheric pressure. Then in this is about the graph drawn for the solvent. This is about the for the solution. Then this we call as a pure solvent, that is this we call as a TB naught, that is the boiling point of the solvent. Then this we call as a boiling point of the solution. Then this difference is there, no? This difference is there, no? Increase in the boiling point is there, no? That we call as a elevation of boiling point. That we call as a elevation of the boiling point. The increase in the boiling point after adding the non-volatile solute to the volatile solvent, the increase in the boiling point is called as a elevation of boiling point. ಏನು increase ಆಗುತ್ತೋ boiling point solution ಏನು ಅದನ್ನ ನಾವು ಏನಂತ ಕರಿತೀವಿ ಅಂದ್ರೆ elevation of boiling point ಅಂತ ಕರಿತೀವಿ. We call it as a elevation of boiling point. Thus that is the increase in the boiling point, that is that we are going to be changing the boiling point, that is delta TB. That is delta TB is the increase in boiling point. Increase in boiling point. Therefore, the delta TB we can be written as delta TB is equal to TB minus TB naught. TB naught means this is going to be this we call as a elevation of boiling point. For the dilute solutions, the elevation of boiling point is directly proportional to molar concentration of the solute. That is molar concentration of the solute. This we can be written as, that is this we can be written as, that is for the experiment shown that for the elevation of boiling point, that is from experiments for dilute solutions, elevation of boiling point of solution is directly proportional to molar concentration of the solute. Molar concentration of the solute means this we can be written as, that is delta TB is directly proportional to the, that is molar concentration of the solute, that is small m. The small m is nothing but molality, that is about the molality. Then therefore this we can be written as delta TB is equal to, that is kdm. Yeah, the kb is nothing but where m is molality of a solution, molar concentration of the solution. We can be written as molar concentration of the solution. Yeah, molarity of the solution. Then TB is equal to Km. KB is nothing but the KB andre enandre that is a constant, the boiling point of elevation, the boiling point, a constant of boiling point of elevation anta karibodu athava ebullioscopic constant anta karibodu. It's also called as a ebullioscopic constant. It is also be called as a constant for the molar concentration, that is constant for the molar concentration. This about the, that is the elevation of boiling point. This by taking this that is KB is nothing but boiling point constant of boiling point of elevation constant. This is constant value, otherwise ebullioscopic constant, otherwise it's called as a ebullioscopic constant. This also be called as a ebullioscopic constant, that is KB is nothing but ebullioscopic constant. Once again I will explain, that is elevation of boiling point is one of the colligative property. This before going to that, we should know that what is meant by boiling point of a liquid. That is the boiling point of a liquid is defined as the temperature at which the atmospheric pressure becomes equal to the, that is the vapor pressure, or atmospheric pressure is equal to the vapor pressure of the, that is the solution, vapor pressure of the liquid. Vapor pressure liquid equal becomes equal to the atmospheric pressure, that we call as a boiling point of a liquid. We know that is the vapor pressure of the solution is lower than the vapor pressure of the solvent. Otherwise we can say that vapor pressure of the that is boiling point of the solution is higher than the boiling point of the, that is the solvent. Now let us consider 1 gram of sucrose in the 1000 gram of water boils at is going to be boils at 373 Kelvin at the atmospheric pressure, 1 atmospheric pressure. Let it be the TB node is the boiling point of the pure solvent, then TB be the boiling point of the solution, then delta TB is the increase in the boiling point. In this graph you can observe that is the temperature is drawn in the x-axis, vapor pressure is going to be drawn in the y-axis. Here what happens, you can observe here temperature is lesser, the TB node is less, that is temperature of the solvent is lesser than the temperature of the solution. Temperature, that is the boiling point of the solution. The boiling point of the solvent is less than the boiling point of the solution, means that is increases when the non-volatile solute is added to the solvent. At that time is going to be increases the boiling point. That increase in boiling point we called as a elevation of boiling point. That is in this from the experiment, that is for the dilute solutions. That is increase in the elevation of boiling point of a solution is directly proportional to the molar concentration of the solution. That is molar concentration of the solution. When it comes to that is TB, that is delta TB is directly proportional to M. M is nothing but M andre enandre molarity of a solution. The dCb is equal to kPm. Kb is nothing but constant. These are, that is elevation constant. Elevation of boiling point constant for the elevation of boiling point, or ebullioscopic constant. Otherwise it will also be called as a molar elevation constant. This about the elevation of boiling point. Now we will discuss about the how to calculate the molar mass from the, that is determination of molar mass of the solute from the elevation of boiling point. Now the determination of molecular mass of solute from the elevation of boiling point. This is very important. Based on this formula, so many times I asked the problems based on this. Now we will discuss about this how to find the that is formula to find the molecular mass of the solute using the elevation of boiling point. In this, you can now let us consider that is the W2 gram of solute of molar mass M2 is dissolved in W1 gram of solvent to form a solution. In this, we know that from the elevation of the boiling point, we got that is the delta TB is equal to KB into M. Here, then the molarity of solution. Take it as this is the equation 1. Then molarity of a solution is given by the expression that is small m is nothing but molarity of the solution, mass of solute in grams, then molecular mass of solute, molar mass of solute, then into 1000 divided by that is mass of solvent in grams. Then we are going to get that M is equal to that is mass of solute is W2 into 1000 divided by molecular mass of solute is M2, that is M2 into that is mass of solvent is W1. Then put the value of M in equation 1. At that time, we are going to be get that delta PV is equal to then KB, that is KB into what we are going to be get, that is W2 into 100 divided by that is M2 into that is W1. On rearranging this equation, we are going to be get that is M2 is equal to that is KB into W2 into 100 divided by delta PV into W1. By knowing the remaining factors, we can calculate the molecular mass or molar mass of the solute. This is nothing but delta TB is nothing but elevation of boiling point, that is increase in the boiling point. The KB is nothing but constant, that is abilioscopic constant, or the constant for that is the elevation of boiling point. Then W2 is that is the mass of the solute. W1 is the mass of the solvent. Then 1000. So we are going to be here. From this equation, we can calculate the molar mass of the solute. Now in this, you should be remember what is meant by elevation of boiling point. The increasing of the boiling point by the addition of non-volatile solute to the volatile solvent. That we called as a elevation of boiling point. This about this is the formula used to calculate the molar mass of the solute in case of the base of the elevation of boiling point.